Hello, everyone. I'm Minsuk. I'm working at Net Zero office of SK Energy. Today, I'm going to talk about low carbon energy. My topic might not be aligned with the other speakers' topics. I want to touch upon some supply chain issues, and there are expectations and concerns about marine fuels, and I'd like to talk about them as well. For 5,500 years, we've used wind power to sail vessels, and it's been only 200 years since we started using fossil fuels. And diesel propulsion was introduced with Titanic. Now we are going back to wind power. We are going back to the natural power. Isn't it ironic? On the left, you can see the picture of a boiler of Titanic. We used coals to power the boiler. When we burn wood, can we call this vessel low-carbon fueled vessels? Yes, we can decarbonize the vessels. Why is it possible? Why is that? We can find the answer from the carbon cycle that we learned at school as kids. Animals fed on organic materials generate emissions, and the CO2 is released to the air, and it creates this cycle. UNIPCC calls biomass a carbon-neutral fuel. But biomass can be divided into different grades. On the left, you can see child labor working on biofuel generation. On the right, you can see some crops and food used to generate biomass. And some lands are burned to generate biomass. On the right, you can see the scraps, wood scraps, and cooking oils, and oil coming out of pork. And at the bottom, you can see food trash. They are all used for biomass generation. And among them, what is the most effective source? When we think about fossil fuel, you will see for human activities, fossil fuels or coals are mined. And that created problems for the past 200 years. Now we are talking about carbon neutrality and coal biomass or carbon neutral fuel. We are developing forests, and we are generating more carbon emissions during the development. So we have to do life cycle assessment to have a clear picture. On the previous slide, I showed you different types of sources for biomass. So how can you decide a fuel is low carbon fuel? This is a complex idea. To quantify sustainability, we use what we call land use. And there is direct and indirect carbon use. The biggest difference here is in carbon use is when you use food as a biofuel, forests were deforested and destroyed, and the lands are used to produce biofuel while destroying forests. And this has been the most important comments when you talk about sustainability for the past few years. Low ILUC risk required certification to learn which fuel sources cause indirect land use. P4 and P5 revisions provided this guideline. Palm oil should be out of the market by 2030. EU divide biofuels into two. One is the first generation using food sources. Under that, there are two parts, Part A and Part B. Part A is spent oil or animal oil. Part A used to be called as a solid oil. And also Part A includes woods, and those resources are used to create wood sources. And this is all part of the second generation biomass. The aviation industry is calculating the sustainability indicator or factors to see the indirect land use. CORSIA is a mechanism for offsetting greenhouse gas emission, and this also requires some credits. So under CORSIA, you can see how biofuel is used to fuel the aviation sector. We also have something called a shaft. On the shaft, the first generation and the second generation biofuels are identified and separated. And as you can see here, the first generation biomass generates more CO2 emissions than fossil fuels. The second generation biofuels generates less. The EU CORSIA Common Sustainability Framework shows that life cycle assessment is required to reduce CO2 emission, and qualification is also dealt here, and it prevents and it prohibits using food to generate biofuel. And EU has another regulation, crop-based biofuel will result in a situation where people will lack food for consumption. Biofuels still are used for road transportation. If international shipping takes biofuels as an alternative fuel, the crop-based fuels will be moved to the marine sector. There has been a concern about it. The IMO ISWG meeting discussed what is similar to what was discussed at EU. It is very difficult to do life cycle assessment for every biofuel or every alternative fuels. So they selected a leading set of alternative fuels, including biofuel, but they applied the same sustainability criteria. But the problem is there are different massing methodologies. EU's and IMO's methodologies are similar. So according to their assessment, the same fuels result in the same results. But if you choose to use another methodology, your results will be different. For example, if you look at red 2, LCA should be graded. It should be grid. Yellow represents grid, and the number is 20% higher than usual. even if it's the same LCA, depending on the methodology you are going to use,
기업의 온실가스 인벤토리가 차이가 나는 부분을 표준화해야 되는 그런 문제가 있을 거라 생각합니다.
to get the accurate results, you have to standardize emissions from each country or each sector. So without a certification for sustainability performance will not be acknowledged or recognized. EU and Korea are using certification organizations to prove a certain fuel's sustainability. IMO, I believe, will take a similar path or approach from production to transportation to consumption. A fuel should be assessed for its sustainability. In other words, if we don't have a certification process, we cannot prove whether the fuel is sustainable. That is what all these mechanisms are about. Compared to fossil fuels, there could be fuels that can reduce greenhouse gas emission by a certain percentage. Next is mass balance. Usually there is only a small amount of low carbon fuels. So it is very difficult to segregate all the tanks or pipelines to store low carbon fuels. Ship owners can't afford to have a separate space for low carbon fuel on ships. Here the mass balance kicks in. So in the future, where you allocate all the outcomes or results will matter. So I think mass balance will be used more in the future. This is about the rule of mass conservation. If you provide a certain amount of input, you will get the same amount of output. In international aviation, for example, let's say an aircraft or airliner cannot find enough alternative fuels. It needs to find a more effective alternative, and IMO will, I believe, come up with a new idea to address that. So when the airliner has a certain amount of credits, they will be able to offset. It will be able to offset its emission. And this is a mechanism for international greenhouse gas emission. Each company has its own corporate activities, and it splits its greenhouse gas emission into different scopes. Direct scope is represented by scope 1, and indirect emission is represented by scope 3. And some part of emission is out of their control, and it is represented by scope 3. And transportation is under scope 3. In a certain particular areas, scope 3 has higher level. And emission from transportation accounts for a large share out of the total emission of a particular company. And ETS or carbon credit system, it was a voluntary measures, but there will be more mandatory in the future. And Korea and EU's measures have something in common. By 2024, all listed companies have to make their data of scope 3 publicly available.
연계를 해라.
And the U.S. has a regulation that requires shipping companies to
동시에 따라서 그런 부분들을 준비할
uncover their scope 1 and 2 results
온실가스 배출은
to the
정확하게
public.
알고 있어야만
So they need to
이제 각 참여자
exactly understand their scope 1 and 2 results and
부합할 수 있는
greenhouse gas emission. Only then they can come up with a business model that will help
활동에 의한 배출이
them meet with GHG reduction regulations. If you compare scope 1, 2, and 3, you can see a large amount of emission comes from scope 3. Musk is a little different. Musk has a high share of scope 3, but H&M
뭐 유로나브 같은 이런 탱커 상사 같은 경우는
or
스코어 1에
tank
40만 톤
or tankers,
배기가스들이
they generate or exhaust
그게 대부분
CO2 or
결국에는
exhaust gases
회사가 온실가스를
that belong to scope 3. Most of the gases come from fuels. If the shipping industry or maritime industry started to use
배출이 감소를 하게 됩니다.
different fuels, scope 3 emission will go down. That is why it is highly recommended low carbon or zero carbon fuels should be used.
21년부터 22년
This shows the order of new ships. In 2021, DF engines accounted for 20% of new orders, but the number is expected to increase this year. But still, 70 to 80% of the engines are conventional engines. This also means ship owners are hesitating to make investments
시스템을 활용할 수 있는
because of uncertainties in the market.
바이오퓨얼이나 이퓨얼
And biofuel and e-fuel
되지 않을까 싶습니다.
can be combined and can be considered, and they are called drop-in fuel.
하지만 지금
And my concern is, personally,
많은 하고 있는데
many new
퓨얼 엔진 중에서
ships are constructed with LNG engines. But think about the number of
그리고 온실가스 감축 효과가 대략
engines, LNG engines, and think about the crisis in Ukraine. It has disrupted the supply chain. Biogas and e-methane
LNG 듀얼 엔진이 지속하게 사용될 수도 있겠지만
can be used for LNG dual fuel engines. But my concern is biogas and e-methane. I'm not sure whether they will be the mainstream fuels in the maritime sector.
고체도 있고요.
There are solid,
듀얼로 바뀌어가는 과정들이
gaseous, and liquid
다이렉트, 즉 고체 바이오매스인 상태에서
biomass.
화력 발전소나 화력 보일러에서 떼서
But solid biomass that can be burned
이용하는 거죠.
at coal-fired power plants, like you burn wood for power generation. And biogas can come from dead animals, and it can eventually generate methane, and it can be liquefied to produce biofuel.
저희가 생각하는 건 바이오 디젤을 생각하는데
When you think about biofuel,
를 활용을 해서 에스테르와 과정을 거쳐서
mostly you think about biomass. And
에스테르와 과정을
methanol
빨리는
can be added, and at the bottom you can get glycerin, that is the raw material of cells, and then you can extract biodiesel out of it.
선박에서 트라이얼로 바이오퓨얼을 사용하고 있는 그런 부분들은
Some ships are trying to use this as a marine fuel, and this process is called flaming.
7% 정도밖에 안 되고요. 바이오 에너지 전체에서는 이 고체 바이오매스
For transportation, only 7% of biofuel in total use is used for transportation, and this is a complicated part. Liquid biofuel, biofuel can be easily converted, but the problem is the wood scrap or crops or vegetable skins, fruit skins. All they require penolysis. This is a thermal degradation to produce biomass. And a synthetic process is also required to liquefy the biofuel. But the problem is that if you input 100% of 100 raw materials, you will get only 20 output. So biofuel will have more competition in the market. So thermal synthesis can create a premium or high-end biofuel, but there are also uncertainties about that. To liquefy biofuel, since biofuel can be easily combined chemically, so it can be easily used as a drop-in fuel. The problem is the oxygen concentration is very high. That means it can be easily going bad. And flaming conventional FO has aspartame, which is a raw material to make asphalt. So there is incompatibility. When this is combined with an incompatible raw material, sludge can be accumulated at the bottom, so there could be a sediment of sludge. And purifier can be used to clean it, but this sludge is very difficult to remove the sludge. And you have heard about the problems of clogging. That this is not biofuel. The problem is not biofuel there. Sludge is the problem. So you have to keep in mind this risk. And flaming you may see that this has better stability compared to FVO, but if it is combined with HVO, there could be risks, and you have to expect the risks. So if you do LCA on each alternative fuel, the first generation of biofuels will generate more CO2 compared to fossil fuels, but premium or high-end biofuels will generate less CO2. This is the key message I'd like to deliver. Many ship owners are considering biofuel combination or using drop-in fuel as a marine fuel. But the challenge is the demand coming from the road transportation can come from the marine sector. And there could be additional demand from the road transportation, and the aviation sector will turn to biofuel as its fuel. So many sectors will compete to have biofuel. So here we have a problem. Do you think the world can come up with produce enough biofuel to meet the demands? And I talked about the first generation or second generation of biofuel in EU and Korea. They want the first generation of biofuel out of the market, and there is uncertainty that their second generation of biofuel can take up all the demand for the first generation biofuel when the first generation of biofuel is out of the market. I doubt it. And another concern is crop-based or food trash-based biofuel. There should be more crop-based materials to meet the global demand for biofuel. Basically, I guess by 2030, there will be a shortage of 15 million tons of biofuel in the world. So biofuel price went up fast, and it is 3 to 4 times more expensive than about 10 years ago. So advantages and disadvantages of alternative fuels, you already heard about them, so I will skip them. What is e-fuel? E-fuel is the combination of renewable hydrogen and other alternative energy. And I'm going to share with you a different perspective from the other speakers. CO2 coming out of fossil fuels are the same fossil fuels. The only difference here is that it is being used for different industries. So we cannot technically call this carbon neutral. That is why I showed you the previous slides. I wanted to provide the exact definition of carbon neutrality. So CO2 emission coming out of other fuels, not fossil fuels, should be called carbon neutral. So I'm talking about concerns about e-fuel, biogenic or carbon neutral CO2 emission. Do you think it is possible to have carbon neutral CO2 emission? If many people are confused that if biofuel is used and not additional CO2 emission is generated, the fuel is carbon neutral. If EU turns to biogenic CO2 emission only by 2035, we won't be able to meet the GHG reduction goals. That is why EU made some compromise. Indirect air capture is very expensive. In the States, the US is the leader in direct capture, air capture. The US is providing carrots instead of sticks. In other words, the country is encouraging investment in direct air capture. So US is way ahead of the other countries. And CO2 capture out of power plants is not a large amount. CO2 captured from traditional fossil fuels, compared to that, this is very expensive. So the carbon price will go up. If fruits are low-hanging, it is very easy to pick them. But they are high-hanging, it will be difficult to pick them. So IMO decided to introduce the carbon pricing mechanism. To achieve energy transition to low carbon or zero carbon emission, I believe carbon pricing is necessary. So I think IMO should refer to CORSIA and other mechanisms similar to CORSIA. And green methanol, its price is $400 per ton. And green methanol will be priced at $1,500 per ton. So until the green methanol's price go down, we will have to wait. I believe some people say by 2050 the price will go down, but I think it will take longer. In ammonia, recently is priced at $2,000 per ton. The same thing can be said of blue hydrogen. In the past, we used to think blue hydrogen's price will go down all year, then green
그린
hydrogen's price.
에너지들이 이제 좀 더
But
가능성을 빨리 올 거라고 생각하고 있습니다.
I think green hydrogen will be more economically feasible.
부분에 대해서는
and-
아까 말씀드렸던 이 분명히 마린 퓨얼에 있어서 이 탄소
When you talk about marine
마린
fuels,
퓨얼이 공급망 안에서 탄소 감축에 크나큰 영향을 할 거라는 거고.
we should recognize that marine fuel will contribute to reducing CO2 emission, and it can contribute to generating zero carbon emission.
그리고 재생 에너지의
And for that, we have to consider
빨리 하락을 되면서
prices
퓨얼 가격이 경제성이
of
최고라는 걸 말씀드렸습니다.
CEOs, and the prices should go down. But the problem is there are some problems with the supply of biofuels and competition between different industries to have biofuel as their mainstream
이런
fuels.
부분들이 이제 앞으로 우리가
And those are challenges we have to
해야 될 것 같습니다.
discuss in the international shipping. Thank you for listening.